Okay, you can still hear me, right?
Yes, sir.
Yes, sir.
All right. So to calculate the mole of this, the mass is 496 divided by molar mass. Molar mass we already calculate that up there to be 124. So help me to calculate this, please. What do we have? 496 divided by 124. What's the answer to that?
4. 4 more.
Okay. That is 4 mole. And this same formula for mole is also same as equal to amount of substance divided by Avogadro's number. Okay, the Avogadro's number, I will just write 6.02 exponential 23 there. 6.02 6.3. So to get the number of molecules, which is the amount, you just multiply this to this side. That goes to multiply that, so you have that to be 4 times 6.02 times 10 to the power 23, and you have that to be 24.08 times 10 to the power 23. That will be the number of molecules. So here capital N denotes molecules, right? So that is that. Do we all understand now?
Yes, sir.
Okay, that's great. Now let's look at the next question then. Question 7. Upon eating 1.25 gram of a solid, 280 centimeter cube of a gas measured at STP, at standard temperature and pressure, were evolved, and a residue of 0.7 gram was left. Calculate the molar mass of the gas. Anyone has idea of how we can go about this? Does anybody has an idea? Anybody or nobody?
So I can't see the question.
Okay, this is the question. Question 7. Upon eating 1.25 gram of a solid, 280 centimeter cube of a gas measured at STP were evolved, and a residue of 0.7 gram was left. Calculate the molar mass of the gas. It's not just possible that you can how should I put it? There is not how in chemistry there is not possible you can escape stoichiometric questions. You will always see at any point in time stoichiometric questions coming your way. So it is best that we try as much as possible to take advantage of it and understand the concept very well. If not, we might have issues interpreting or solving questions under stoichiometry. So for this question now, it is said that a solid was heated, and when you eat the solid, it gives out a gas, and the gas has a volume measured at STP, and a residue of the gas of the solid was also measured, weighing about 0.7 grams. So you have to calculate the molar mass of the gas. Okay. So questions like this are just kind of logical. So let us explain it in detail. Can we all see this screen?
Yes,
Question.
sir.
Yes, sir.
Yes,
Okay.
sir.
Okay, thank you so much for that. So, what the question is saying, oh, that's too tiny. Give me some minutes. Let me check. Why is it? Oh, 13%. That's a very, very small.
Yeah, before Mr. Okpa finish setting that, please everybody know that there is English class tomorrow between 5 to 6. English class tomorrow between 5 to 6. So the link will be dropped on the group. So be aware. Thank you.
Okay. So, what kind of pen is this one? English class tomorrow. Okay. Um, let's just use this one. Ah, I don't know what's wrong with the pen all of a sudden, but then the clarity is. Let me zoom in properly. Alright, so I think it was very good. I think this is better. Alright, so let's analyze the question this way. Okay. So you have something like this. Okay. Sorry is kind of not vegetable. We can very well manage the diagram. So this, let me say this measuring instrument here is calibrated in grams. It's calibrated in grams. So meaning that it is supposed to weigh an object, to get the mass of an object. So suppose you add a particular object here. Okay, don't let me use that arrow. Let me just use the red ink to indicate that you add or you place an object inside this place here. So this is an object, and then you kind of supply it to this container. There are sources of heat coming by the side way. So the solid that you have inside this container, suddenly you just have gases coming off. So over time, as those gases are being given off, you have a reduction in size of the solid that you have in here. That reduction, we are left with residue. Are we all getting what I'm saying, please?
Yes, sir.
Okay. Now the volume of the gas that is coming out, it is 280 centimeter cube. You're giving the volume. The volume is given to be 280 centimeter cube, and this is measured at STP. When we are talking about STP, that's standard temperature and pressure. Standard temperature and pressure. And what's the standard temperature? Standard temperature is 0 degrees C, right? 0 degrees C, which is same as 273 Kelvin, which is same thing as 32 degrees Fahrenheit. Standard pressure, that is what atmosphere, 760 millimeter of mercury, which is same as 760 to Uceli top, which is same as 1.01325 and instead is per 5 Newton per meter square or Pascal. So that one, by the way. So the volume is given. Now the mass of that residue is now measured on the scale. We are given the mass of the residue. The mass of the residue is measured on the scale to be 0.7 grams left. Let's just use that as a spot of the measured something. So 0.7 gram and initial mass of the solid. Let me put it up here. That original mass of solid. That was given to be, what's that value again? 1.25 grams. So this is an analysis. 1.25 grams is the original mass of the solid. When you heat it up, it gives off gases or a gas, and the volume of the gas is measured to be 280 centimeter cube at standard temperature and pressure, and is now leaving a residue. Yes, is leaving a residue of 0.7 grams. So which implies that most likely part of this solid has been given off in form of a volume, right? Now this given volume that you have here, there's a way we calculate. There's a formula that relates mole with volume as well. I don't know if I give us that formula. You should as well know that mole can be calculated using mole is equals to volume of a gas divided by molar gas volume. And this molar gas volume, you need to take note of that to be 22.4 gmq per mole. Are we together? So molar gas volume 22.4 gmq per mole. So the question says calculate the molar mass of the gas. It's very straightforward. You already have the volume of the gas, 280 centimeter cube. From this given volume of the gas, you can use it to calculate the mole. You can use it to calculate the mole of the gas. After getting the mole of the gas, if you are given original mass of the solid of the solid to be 1.25 and is leaving a residue of 0.7 gram. Remember I stated that means that part of this solid, a particular mass of the solid has been converted to this gas. So which means that you can simply get the mass of the gas by subtracting 0.7 from 1.25 grams. So let's work that on the whiteboard. So this implies that mass of solid 1.25 gram mass of residue is equal to 0.7 gram. The mass of gas will be what? Equals to 1.25 minus 0.7. 1.25 minus 0.7. What do we have, please? Somebody help with that. So on the other side, I will be solving for mole. We're given 250 centimeter cube. Who is calculating mass of gas for me? Divided by, oh, that is 280, sorry.
0.55.
Zero point what?
55.
0.55. That is mass of the gas. Now you want to solve for the mole of the gas. Now this is 280 centimeter cube. That's the volume of the gas. Divided by molar gas volume. That is 22.4 dm cube. There is a way, you can't work with centimeter cube and dm cube. You either convert this centimeter cube to dm cube and solve, or you convert dm cube to centimeter cube and you solve. So in this case, I'm working with centimeter cube, so I will need to convert this dm cube to what? To centimeter cube. So 22.4 dm cube will be equals to 22,400 centimeter cube. Why? The reason why is because 1 decimeter cube is equals to 1000 centimeter cube. So you simply multiply this value by what? 1000. So you have 22400. So this 280 divided by 22400. Someone calculate this for me, please. And that will be centimeter cube per mole. Centimeter cube per mole. Centimeter cube per mole. At times when you are working together with units, it give you an insight of what your final unit will be. So this will cancel out this. So our answer, someone calculating that for me, please. Who is calculating?
0.0125 mole.
0.0125 mole. Thank you. So this is the mole of the gas now. This is the mass of the gas, 0.55. This is the mole, is 0.0125. So from here, you can simply proceed to solve for the molar mass of the gas. Molar mass of gas can then be solved for by saying that molar mass of the gas will be equal to what? Mass divided by mole, right? We have mass divided by mole. Mole is equal to mass over molar mass. So when you swap their position, you have molar mass is equal to mass divided by mole. So what is the mass now? The mass is 0.55 and the mole is 0.0125. So you have 0.55 rather divided by 0.0125. So when you solve for this, what do you have, people? What will be our value?
44.
You have 44 grams per mole. It is molar mass, right? So 44 grams per mole. At times, molar mass at times could be written in just in grams. However, at times you can write it as 44 grams per mole. Okay. So most of the questions here, you should be able to solve them according to what we've solved here. The other cases will be okay. So very quickly, the assignments I'm going to give us will be solve the questions on this page. So I'm going to screenshot that now and send to the platform for you to have access. Okay. Going to screenshot that now. So